So thank you for staying to the bitter end. The best part will be Roberto's summation at the end. I can't wait. I'll be taking a nap over there in the corner. But we have one more excellent speaker for you this afternoon. There hasn't been a lot of conversation about cloud computing. There's been some, but not a lot. And so it's time to think about, now that we're considering moving so much data from our own data centers into the cloud, how do we think about protecting that data, protecting the private data, and keeping it secure? So our final speaker for the day from Amazon Web Services is Simone Bonazzi. Yes, please, before you leave, don't leave while Simone is speaking, because he's a great speaker. But when you do leave, please do fill out the evaluation form. If you don't have an evaluation form, we'll bring you one. Thank you.
Is this on?
Try again.
Hello? Is this on? Hello? It says low battery. I can use this.
Yeah.
Can you hear me?
Yes.
No, and this is the clicker, right? Yeah. Okay. So, last speaker of the day. What an honor, right? My name is Simone. I speak very little Spanish. Hablo un poquito de español. But I don't speak it well enough to speak in Spanish. So I will go to my broken English, or we can do it in Italian. Of course, English is better. So I work for this little bookstore called Amazon.com. Are you familiar with Amazon? Raise your hand. Okay. Do you buy stuff on Amazon? Raise your hand. Good. For the ones that didn't raise their hand, we have to talk in private later. I'm kidding. So Amazon.com is a big business. It's a $126 billion business, almost 90,000 employees. But what's important about it is that there is the retail business, which you probably know well, and there's another business called Amazon Web Services. Those are all part of the same company. And Amazon Web Services was started a few years ago, and this is the cloud computing division of Amazon.com. So we're talking about a global cloud infrastructure. Essentially, from your laptop, you can log in, access your account, and then create machines, virtual machines, use storage, move data around, etc. So this is what we're going to talk about. And in particular, I want to focus on security in the cloud. I have one good news for you. Since it's 4:40, at what time are we supposed to end? At 5? A little later? Okay. I will finish my talk at 5, and then I will leave room for questions, and we can have as many questions as you want. But if you want to leave earlier, you're free to leave after, at 5 essentially, so a little bit earlier than expected. So now we'll focus on the security aspects of the cloud. So first question is, what is cloud computing? We've been hearing about cloud computing for many years now, and most people usually separate IT infrastructure between physical data centers and everything else, where everything else means instead of owning the computers, the servers, the storage, and the data centers, or renting it out, I'm instead using cloud computing. So I'm using some infrastructure that another company is providing, of course, for a price. And Amazon provides such type of infrastructure. There are many acronyms used by Amazon Web Services. I don't want to focus too much on Amazon Web Services, but those are the building blocks, the main pieces, the Lego blocks that you might want to use if you want to create an infrastructure that can, of course, serve your business. For example, if I want to run a company that offers software as a service, this is a common thing today, I might need to have virtual servers. I want virtual disks for those servers. I want storage for my backups and archives. I might want to use some databases. I can either run them on those virtual servers and manage them by myself, or I can use the pre-built, ready-to-use databases that a cloud provider offers. And then there are many other services that are just, they just add value to those basic, very important building blocks of a cloud computing platform. And what's very important is that in the case of Amazon Web Services, and I think in the case of most of the successful and good cloud providers nowadays, everything is offered through an API call. And as you know, APIs, application program interfaces, are essentially a way for multiple pieces of software to talk together using a common language. Very important, it's a way for those pieces to be updated or changed without letting everybody else know what the changes are, as long as the interface remains the same. And very important, if I have many web services, so many little pieces, those are easier to scale. For example, Amazon.com, the retail business. The website, Amazon.com, when you go on Amazon.com, that page is created by hundreds of different web services. Each one of them has a particular function. For example, when you click on a book or a camera, there is one web service that tells you how many items you have in your cart. One web service that tells you how many stars that product has. One that gives you the pictures, one that gives you the description, one that gives you the comments, etc., etc. And the fact that I am dividing my page, in this case, across many web services means that, first of all, if one of those services doesn't work, the page can still be loaded and there will be one little piece missing, but everything else will be there. So my experience will not be perfect, but it will be very close to perfect. Maybe I am missing the number of stars, but everything else is there. Second point, there are some aspects of my business, whatever the business is, in which I might not know when and how to scale, or in which one particular part scales much more widely than the others. As an example, if I have a web application and all of a sudden some websites talk about my web applications, like Slashdot or TechCrunch or Dig, then a lot of traffic comes to my website or to my application, and all of a sudden I have a problem. I need to scale very fast. There's no way for me to predict that need to scale. So if I divide into many web services, and at the same time, if I can provision or deprovision capacity whenever I need it, then I have a very flexible infrastructure that becomes much more powerful than a static, traditional data center. But so why do I want to use the cloud then? One, flexibility, the ability to scale, to use API calls to do anything. Cost savings, because if I only need the infrastructure, if I only use the infrastructure that I need, and I pay only for that, it means that I'm saving a lot of money on unused infrastructure capacity. It means that I can run globally from day one. If I want to launch a new business now, and I want to be in Singapore, in Tokyo, in Sao Paulo, in Europe, in America, I can launch virtual servers, use storage, launch virtual disks, databases, etc. in any of those regions, or in all of them, just from my laptop. very quickly. And another reason is that I can also have the agility to rapidly change the infrastructure that I'm using. Being, for example, for dev and test, if I want to test a new version of my site, I can just provision new infrastructure, test it. If I like it, I can switch my DNS servers to the new infrastructure. If I don't like it, I can just kill it. And this new second infrastructure, I can pay it by the hour. So it can cost me a few dollars just to test a new version of my website, of my product, of my service, and make sure that it works. So those are the main benefits of why I want to use the cloud. An example is the storage service. It's called Amazon S3, stands for Simple Storage Service. So this, oops, I went ahead too fast. One more back. Okay. So this is a graph that shows you how many objects or files are stored on Amazon S3. And the blue line there is at the end of Q1 2013, so 3 months ago. And that is over 2 trillion objects, so 2,000 billion objects. And in fact, many companies are using it. And many of those companies are using it for different purposes. So remember, I told you those are building blocks. Different companies use those building blocks differently. For example, Dropbox. How many of you use Dropbox? Raise your hand. Okay, a few, probably 30%. Dropbox is a very popular backup solution for your files. You can use it on your computer, on multiple computers. You can share files among Dropbox users. And they use Amazon S3, and they store several petabytes of data on Amazon S3. So they use it mostly for backups. Netflix uses it also to host static pictures or static files for their website, or to host different versions of the same video at different resolutions or with different bitrate. The New York Times uses it to store old issues of the New York Times that you can eventually search if you want to, etc., etc. But what about security? Because so far I just made an introduction on cloud computing and how people use it. But what about security? We can talk about security for storage, and we can also talk about security for virtual servers later on. So the point is, I don't physically control that storage. If I use Amazon S3 or any other cloud storage solution, those disks are somewhere in an undescript location, far away. I cannot touch them, I cannot kick them if they don't work, I cannot take them away, I cannot add my own disks. I cannot do anything physical with those devices. And this is true for virtual servers as well. Which means I rely on 2 specific subjects to trust the security of those devices. One is the cloud provider. Second is the auditors of that cloud provider and the certifications that that cloud provider obtains. But there's also a third one that I should trust, which is myself and my ability to, for example, encrypt data when I want to put it on the cloud. So there are many differences in the way that security is managed when I'm using the cloud, even if it's conceptually very similar to the way I would treat my own security. And certifications are very important because if I compare security in the physical world for my own devices, my own infrastructure, I can just walk into my data center and make sure that my colleagues, my teams, are doing what's proper, what's right to ensure the level of security that I want. For example, if I want my facilities to be accessed only by personnel that is authorized and authenticated, at least with the 2 different authentication methods, I can do and check that my infrastructure is set up this way. In the cloud, I rely on auditors that will tell me this cloud provider is following those rules, and I'm auditing it every few months, every few weeks, depending on the certification, to make sure that this cloud provider complies with those guidelines and rules. And some of those certifications are particularly important. A few years ago, no cloud provider had any of those certifications. Today, Amazon is probably the biggest cloud provider on the market, and it's also the one with the longest longest list of security certifications. Some of them talk about security in itself. Some of them are specific to a sector, like HIPAA, which is specific to healthcare in the US. Some of them talk about storage. For example, storage decommissioning, which is something that people underlook most of the time. What happens when a storage device reaches end of life? In our case, based on some certifications that are used by the CIA as well, to make sure that those devices are completely erased, they take the disk, they erase the disk and then write randomly multiple times, then they shred the disk and they recycle it. So there's no way that someone can take those disks and find out what was in those disks before. So storage decommissioning is one of those aspects which is particularly important in securing my data, even when my devices have reached end of life. But all of those things, all of those aspects, if I have to manage them by myself, they also represent a cost, right? If I have my own infrastructure, if I have my own devices, I either pay someone or I personally take care of storage decommissioning. I personally take care of firewalls. I personally take care of physical security. I take care of network security. And there are some things that are much better at scale. Let me give you an example. Amazon uses a virtualization layer. We use Xen, X-E-N, as a hypervisor. It's a heavily customized version of Xen. So we have physical machines. We have the Xen hypervisor. On top of it, we have virtual machines. And as you know, the physical network ports of the physical machines are then mapped into the virtual machines. If I launch a virtual server on Amazon, and then I want to do IP spoofing, which is a technique in which I essentially try to spoof the IP address of packets. So I try to steal some communication in that network. Since I'm using a virtual network port, the hypervisor will notice that I'm trying to attack, to perform a security attack, and it will just stop me. It will just prevent me from doing that. So by using this technology, in this particular case, some of the most common network level attacks are not possible because the physical machine is not controlled by me, it's controlled by a hypervisor. So some things like this work much better at scale when there is a cloud provider big enough to invest a lot of money in ensuring that the security of every system is the highest possible. So as a client, when you are thinking, should I use my physical infrastructure or should I use the cloud? And when you're worried that the cloud might be different, might be weaker, etc., you should also include cost in the equation, because many things that you take for granted, they actually represent a cost. In the case of cloud providers like this one, many of those things are given essentially for free as part of the package. You don't pay extra for that. But then the next question can be, okay, I get it, I'm interested, but if I need to do something in the cloud, and this could be, I need to run an Oracle database, I need to run an SAP software, I need to create a DMZ or multiple ones. So can I do that part in the cloud? Well, the good news is that in the last few years, cloud computing has become mainstream. And this means that the market is big enough for specific security solutions. And I will give you only one example. I could give you a list of 50 things, but one example is HSM. HSM means Hardware Security Module. If you are a big enterprise and you want to manage your own encryption, you use a physical device that you can, of course, replicate across multiple sites. And those physical devices are initially, let's say, set up with your encrypted keys in such a way that those devices can be stolen and your keys are protected. But at the same time, if you want to use communication between two endpoints and you are using those devices, the communication between those two endpoints is secure. So if you have this need, which might be because you are a bank, because you have a specific certification that you need to follow, or because your internal guidelines require so. Shell, for example, the logo I showed you before is the Shell oil company. Shell has this need for almost every product. Well, this is a service that we offer. We started offering it a few months ago. You can essentially set up your HSM in the cloud, and then you can start using it also with your virtual machines inside the cloud. So this is something that gives you a hint of what's happening in the cloud computing space. All those features that until a few years ago were only available if you owned the hardware, they were only available in physical data centers. All those features are now getting available also in the cloud. Maybe not all of them, but many of them are available now, and many are being added every day. Which means there are fewer and fewer reasons to say, I cannot use the cloud because those two security features are not available. Well, I might say maybe they're not available yet, but they are likely to be available very soon. And actually, most of the time, the features you need are already available. So I told you that I was going to be brief, that I was going to stop at 5. It's 3 minutes to 5. And I want to just draw a couple of conclusions before we can open the floor for questions. And then if you want, you can go before the questions start. So you are probably very familiar with how security works in a traditional environment. And by traditional, I'm not saying that it's worse. I'm just saying the one that you're familiar with, the usual one, the physical infrastructure. Cloud computing brings many benefits, and it doesn't mean this is an all or nothing proposition. It doesn't mean you either choose, you go in the cloud or you stay in the physical world. You can actually mix those two things very well. Actually, most people, most customers, they have a combination of physical infrastructure and cloud computing infrastructure because it makes sense. There are some things in which you're already invested into. You already bought a data center. Why should you throw it away? Keep using it, but for new things that will require new hardware, maybe you can consider the cloud. This is what some people call hybrid clouds, in which you have something in a physical world and something in the cloud. But when it goes to security, first of all, many of the same rules apply in the cloud. Many features are actually available, most of the time by default. For example, EC2, the virtual server that we offer, is isolated by default. So even if you have a virtual machine and someone else has another virtual machine running on the same physical machine, there is no way those two machines can see each other, or no way that one of those two users can attack the other, even if they are in the same physical machine. This is called instance isolation. Instance is a virtual server, an instance of a virtual server. The isolation means that there's no way for that machine to see or attack the other machine. And this is something offered by default. And as you can guess, a cloud provider comes to you and tells you, give me your credit card, give me your phone number, I will create an account for you, and you have to trust me. You will never see a data center. You will never touch a server. And you have just to trust me. So to earn this trust, you can guess that we should be very, very focused on security. Unless our security is our top priority, there's no way to convince customers to abandon physical servers that they can touch and move their important workloads or their important data to the cloud. So huge investments have been done on security, and this is why many of the existing features or default features are most of the time even better than what you can have on your physical environment. I want to close this with just one mention. The main CIO of the CIA about a year ago declared that security in the cloud is actually higher for their systems than the security that they can have on physical infrastructure. He was talking about specific types of applications, of course. Not all workloads or all applications are the same, but he was clearly showing that given that there is a huge investment in large-scale security, most of the time what you can get from the cloud is cheaper, better, and harder to break than this level of security that you can have on physical infrastructure. And I'm not saying you should trust me or saying that you should just go for the cloud all in from tomorrow, but I'm saying that this is something you should consider, because your competitors are considering it as well. And if this gives you flexibility, agility, and cost savings, you want to reap those benefits, possibly before your competitors do, or together with your competitors. You don't want to be left behind. So, gracias. And now I will just accept a few questions before everybody can finally get out. And of course, first, before I do this, I want to thank everybody for inviting me at this conference. It has been a great event, great location, I think. So, gracias, muchas gracias. Questions? Thanks.
Preguntas?
I think the applause is for finishing earlier, right?
I had a question.
Yes, sure.
I have a question.
Sure.
Like, for all the same reasons that users, customers should move to the cloud, aren't all the hackers that ever there was also going to attack the cloud like every day, all day long?
Yes. The question is?
The question is, you're creating a danger zone. The bigger you get, the more concentration of data and valuable assets you have, the more they're going to focus into attacking you.
Yes, it's a very good point. And I want to be very specific with the answer, because it's a very good point. There are two aspects that are very important to consider. First of all, the bigger, and of course in this case I'm talking about Amazon in specific. I'm describing things that we do at Amazon Web Services. So the first thing is, the bigger we get, the bigger the investment in security that we do, which means, for example, that we have a dedicated team of security experts that is checking our system 24/7. This, as a result, means that, let's say you have a DDoS attack against your systems. We detect it, we start mitigating it, we contact you, and we work with you as the customer to decide two things. This is great. One option is the usual one. I'm having a DDoS attack on my system. Let's mitigate it by trying to quarantine the specific IP addresses or specific requests, etc. And that's the usual standard procedure. The other option, which happened a few times with a few customers, is that, okay, we are currently running, let's say, 200 servers, and we cannot cope with the DDoS attack. Let's scale to 1,000 servers. Now, in 2-3 hours. We scale, and then all of a sudden, the DDoS attack is not a problem anymore. And I have time, even if this takes a few days, I have time to take a look at what's going on, quarantine things, to essentially mitigate the attack without disrupting the service. And you might wonder, wait a minute, I'm going from 200 machines to 1,000, this is going to cost me millions of dollars. No, it's going to cost you a few cents an hour per machine, which means maybe 800 machines, let's say $15,000 a day or something like this. You might say, oh, this is a very expensive thing. But this is an option you have. You can either take the hit and say, this attack is succeeding, I want to mitigate the attack, but it will take days. Or you can say, you know what, let me screw a few bucks and essentially get back to these attackers. And in some cases, the attack stops because they realize they're not succeeding, even without the mitigation part. So this is one aspect. The second aspect is we're getting more mainstream, and it's so easy to start using infrastructure that the danger is that a user that is not proficient in security will get in, sign up, launch servers, and those servers will be highly unsecure by default. You have control of those servers. You have the keys to those servers. We don't. So if you don't make them secure, those are pretty weak against smart attackers. So what we are doing is we are trying to improve the default security as high as possible. And a couple of examples. First example, you sign up, you launch 10 servers, and you try to connect to those servers. It doesn't work. And you say, okay, what's going on? I cannot even connect SSH into my servers. The reason is, by default, the built-in firewall, we call them security groups, is blocked on all ports. So unless you explicitly open those ports, which means you know what you're doing, there's no way to even touch those servers, either by you or by an attacker. Another example is something called the Trusted Advisor. This is an automated feature that we have that analyzes your infrastructure, your deployment, and tells you you have some cost savings opportunities, you have some availability things you should improve, and you have some security concerns that you might want to take a look at. So we tell you you have many ports open, we tell you your system has not been patched, etc., etc. So we proactively give you advice on how to be more secure in the cloud. And by doing those two things combined, so huge investments to make default security better, and trying to educate and help customers to get their security raised, by doing those two things together, I think we've been actually quite successful in maintaining the level of security at an acceptable level. Good question, thanks. Any other question? I think you're all tired, so thank you very much.